So yesterday our last topic is Ether channel. So Ether channel lab is pending. Firstly, we'll complete STP spanning tree protocol, and then we'll do the Ether channel lab. So next topic is STP. Spanning tree protocol. STP is used to avoid layer 2 loops in redundant network. Now, redundant network means we have multiple connection between the devices, like this way. So if we have redundant connectivity, in that case, there is chances of loop. So STP is used to avoid the loops into the Cisco switches. STP is by default enabled in Cisco switches. So now let's assume if there is no STP, then how the loop will form? Let's say we have this type of connectivity. Here, this PC is having MAC address A, and this PC is having MAC address B. In this scenario, right now, no STP. STP is not running here right now. So if STP is not running, then what will be the issues? So first thing, if STP is not running, so what will happen? This PC1 sending a ping request to PCB. This PC. So what will happen? Switch number 1 receive a frame from switch number 1 on port number 1. So what switch will do? Switch will firstly perform first functionality, address learning. So in address learning, on the switch number 1, it will note down I receive a frame from fast Ethernet 0/1 and the source MAC is AAA and the destination MAC is unknown. Like this way. So if destination MAC is this, this packet will forward to both the links, right? Hold on this packet right now. Let's process this packet. So through 0/2 port number, it is received by switch number 2. So what switch number 2 will do? Same process. It receive a frame from fast Ethernet 0/1 and the source MAC is AAA and the destination MAC is Let's say this one. Now, same process happen. The packet will forward to both the links. So this destination received a frame, but the same packet again received by the switch number 1 on port number 0/3, AAA and FFF. Clear this process. Any question here? And this process will continue. And this packet is revolving in your network. First thing. Second, this destination is receiving multiple copy. And same process will be done through this packet. Through this packet. So this is loop.
Okay, it didn't make sense until you put the blue arrows. That makes, okay.
Clear? So the packet, which is unnecessary packet, which is revolving into the network, that is known as a loop. Why it happens? Yeah.
What are some of the symptoms of a loop?
Okay. For example, there is a layer 2 loops in your network. So on the switches, there are LEDs. On the port, let's say the port number is fast Ethernet 0/1. Above that port number, there is a LED. If there is a loop, that will blink continuously. Okay. Physically, we can identify like this way. Otherwise, let's say if you have any monitoring PC, let's say in your company you have any monitoring server. In that case, on that monitoring server, you will get continuous copies. Through FFFFFF. So that will be the case if STP is not working. And that loop will form because we had redundant topology. And in that redundant topology, there is no STP. So what will be the solution for that? Solution is, if we remove one link, the problem is resolved. But if we remove one link, then there will be no redundancy. Clear? Redundancy we require. Now, second option, we can manually shut down that another link. But the same problem, if we manually shut down that port, if something happened to the primary link, we had to manually enable that port. So it's like we are removing one link. So now the solution is STP. Now what STP will do, in STP, one link will become the primary link and another link will become secondary link. So my all data will travel through the primary link. Once primary link goes down, then secondary will become primary. Clear this thing?
So you're basically just putting the second link on standby.
Right. It's not like second link. Let's say if you put here 4 link. One link will be the primary and rest of 4 link will be the standby. STP will allow only one link to forward the traffic.
Okay, so they're still, they're enabled, but they're not active.
Right.
Okay.
Okay. So if STP not working, then wrong entry in MAC table. Wrong entry in MAC table means if you see this output, there is a MAC address AAA, and this table is showing that MAC address is connecting to the 2 port, which is not possible. One MAC address can be connected only on one port, right? One PC can be connected only on one port. Clear this thing? This PC either can be connected on 0 by 1 or 0 by 3. Second point, duplicate copy received by destination. This packet is revolving. Every time this PC B will receive a packet, it is not giving that acknowledgement, okay, I received that packet, don't send me another copy. No. Every time whenever it receive a copy and it find there is a destination address of B, it will receive that copy. Third point, unwanted traffic revolve in network, which is loops. Any question here?
No, that makes sense.
Next. So now solution is STP. So we have to discuss how that STP is working. STP. So STP used to avoid loops. We'll discuss that thing, how it avoid the loops. STP flavors. In STP we have STP, also known as PVST, then RSTP, then third one is MSTP. So normally STP is known as PVST. PVST is per VLAN spanning tree. And the code is 802.1D. RSTP, rapid spanning tree. 802.1W. MSTP, multiple spanning tree. 802.1S. So these are the codes, IEEE standards. Now, remember one important point. STP is working on every port as well as on every VLANs. Every VLAN. Okay, that's why it is PVST, per VLAN spanning tree. Next point. How STP works. Let us assume we have this topology. switch 1, switch 2. Every switch is having a unique MAC address, and on every port there is a MAC address. So let's assume on this switch 1 the MAC address is AAA, on switch 2 MAC address is BBB, and here the MAC address is C. Now, how STP works? STP complete their task in 3 steps. Election of root bridge, then election of root port, third, election of designated port, and block port. These are the 3 functionality. So we have to discuss all these 3 steps. So now first point. Election of root bridge, first point. So root bridge is like a master switch in the network. Let's say in your company you have 100 of switches. So from the 100 switches, one switch will be the master switch, which is known as the root bridge. Bridge is like your switch. So now, switch which is having lowest bridge ID that switch will be root bridge. That switch will be the root bridge. Now, so root bridge is depend on the bridge ID. So now what is the bridge ID? Bridge ID is 8-byte data which is combination of switch priority plus MAC address. MAC address of the switch. MAC address is unique, and on every switch, by default switch priority is 32768. This is the default priority on every switch. So 32768, 32768, 32768. And MAC address is the unique MAC address, for example, ABC. In bridge ID, firstly, priority check. Lower priority switch will be root bridge. Next point. If priority tie, then lower MAC address bin. Clear these 2 points. So read this statement carefully and let me know which switch will be the root bridge, switch 1, 2 or 3.
Well, so I have a question then. So obviously switch 1 is going to be the root bridge because it's got the lowest MAC address.
Right.
But if you wanted switch 2 to be the root, then you would have to change the ID number, right? The priority number?
Right. Because we cannot change the MAC address.
Right.
I will tell you the command, what will be the command to change the priority. Firstly, we'll discuss
Okay.
the complete theory part.
Does it really make a difference on which one is your root bridge?
Yes, it depends. Like, okay, you have 100 of switches, so you have to select root bridge that switch which is having enough memory resource and enough CPU processing. If there is a lower end switch, let's say 2950, 2960, there is no point to make that switch as a root bridge because that switch is not capable to handle the complete functionality of the switching network.
I see. So you would want your root bridge to be your higher end switch.
Right. Second point, selection of root port. So same network. So due to the first step, 32768, 32768, 32768.
Is there a specific reason why the default is 32768?
No, it's not any specific reason. Cisco make a choose a default middle value, okay, and they put it as a default priority. So root bridge we elected. So now next thing is root ports. Root ports are shortest path cost to reach root bridge. First thing. Now root port always exist on known root bridges. For example, switch number 2 and 3. Only one port can be a root port on one switch. So root port are the shortest path cost to reach the root bridge. So now what is that path cost?
It's the shortest hop.
Yes. Speed. So now path cost depend on the speed. Let's say if your speed is 10 Mbps, the path cost value will be 100. If the speed is 100 Mbps, the path cost value will be 19. If speed is 1 Gbps, the path cost value will be 4. The speed is 10 Gbps, the path cost value will be 2. These values are fixed from the Cisco. Lower the path cost, port will be root. So on switch, let us assume my all interfaces are fast Ethernet interfaces. All interfaces are fast Ethernet. So in that case, if I'm on switch number 2 and if I'm going to the root bridge, so the path cost will be 19 here. On this path 19 and 19. So if I'm going directly, the path cost value will be 19. If I'm going via this lower path, then 19 plus 19, 38. So which one will be the lowest one? The direct connected? So
Yes.
that port will be the root port. Same way, for the switch number 3, the direct port will be the root port. Any question here?
So maybe I'm getting ahead, but so basically what you're saying then is, say the ports on switch 2 and switch 3, the connecting ports there, if those were 1 gigabit ports, and then the 0.1 on switch 3 and the 0.2 on switch 1 were 1 gigabit as well, but then the ports connecting switch 1 and switch 2 were still only fast Ethernet, then your fastest route is going to be from 2 to 3 to 1.
Let me take it.
Because the total would only end up being 16 as opposed to 19.
This is a fast Ethernet here, fast Ethernet, and fast Ethernet. Let me change this topology. Let's say we have this topology. Let us assume this link is the fast Ethernet. This link is the gigabit, and this is the gigabit. So this is the root. Okay. So now, if you see carefully, as I told you, on the fast Ethernet, the path cost value will be 19. So here is 19. On gigabit Ethernet, the path cost value will be 4. So 4 and 4. Clear? So this is the root bridge. So root port. If you are on the switch number 2, so there are 2 ports. One is this, one is this. So now, if I'm going through the lower path, 4 plus 4, 8. So this time, this port will become the root port. And for this switch, this port will be the root port. Clear now?
So
Yes,
when
please.
you're adding up the path cost, you don't do it per port, you do it per connection?
Right.
Okay.
Yes, Daniel, any question?
No, that makes sense.
last point. Selection of designated port and block port. The first thing. Designated port are forwarding ports. Data forwarding ports. On route bridge, all ports are designated. On route bridge, all ports are designated. Now, on non-route bridge switch having lower bridge ID that switch port will be designated. Block port. Block port is used to avoid loops on non-route bridge which is having higher bridge ID. That switch port will be block port. So now so if this is the route bridge, that means these two ports are DP ports, designated port. Now I'm taking all interfaces are fast Ethernet, so this port will be the RP. Here this port will be the RP. So now the election will happen between switch number 2 and switch number 3. If both the ports are designated, in that case loop will form, because designated port means open port. If both the interfaces are designated, in that case loop will form. So one of the port will be into the block port. So which port will be the block? So that is based on these statements. So on the non-route bridges, they will compare the bridge ID. So obviously switch number 2 is having the lower bridge ID. So this port will be the DP and this port will be the block port. Any confusion here?
No, not at this time.
Now, the next question, how the switch knows about each other? Means my priority is this, your MAC address is this. So something happened between the switches. They are exchanging with each other, right? So that thing is BPDU. So BPDU is Bridge Protocol Data Unit. Bridge Protocol Data Unit. It's a kind of hello packet which carry bridge ID of switches. Clear this thing? So every switch will send first time BPDU. BPDU hello. 2 seconds. BPDU max stage 20 seconds. Every switch will send BPDU in 2 seconds. If I'm not receiving any BPDU from the neighboring switch, so how much time I will wait? I will wait maximum 20 seconds. BPDU is basically two types. One is configuration BPDU and one is TCN, topology change notification. So configuration BPDU travel at the first time and every 2 seconds, which contain the bridge ID information. And TCN BPDU will travel only in that case if there is a change into the topology. Maybe some link goes down. If some link goes down, then your root port, designated port will change. So that comes under TCN BPDU. Clear this thing? STP states. In STP, we have 5 states: disable, listening, learning, forwarding, and block. Disable. Disable means no BPDU received. Listening state, BPDU received from the neighbor. Learning means open the BPDU, which is received from the neighbor. Forwarding, forward BPDU on BPDU forwarding. Block state, listen and learn BPDU, but not forward. No. Listening to learning, it takes 15 seconds. Learning to forwarding, again it takes 15 seconds. This 15 second is known as forwarding delay. Total STP convergence time. So 15 plus 15 plus 20, 50 seconds. 15 plus 15, 15 listening to learning, learning to forwarding, and this 20 is the max age timer. So total STP can take 50 seconds to synchronize the topology. That means if something happened to the STP topology, it can take to stabilize the topology maximum 50 seconds. Clear this point? So this 50 seconds is a huge time into the production environment just to synchronize the topology. Now, after that, Cisco modified this protocol and they came up with the solution RSTP. Rapid Spanning Tree Protocol. RSTP convergence time is 10 times less than STP. 10 times less than STP. So that means if STP is taking 50 seconds to synchronize the topology, RSTP will take only 5 seconds. So that is more faster. And rest of the process is exactly same. Like election of root bridge, election of root port, election of designated port and block port, everything is same. Next is MSTP. MSTP is not here, MSTP is into the CCNP basically, but let me give you an overview. MSTP is used MSTP. Is used to combine multiple spanning tree database into a single instance. Used to combine multiple spanning tree database into a single instance. So it's like this way. Let's say on the switch there are 100 of VLANs. So if there are 100 of VLAN, those 100 VLAN will create their own spanning tree database. So that means every VLAN is having a separate spanning tree database. So switch has to remember the complete 100 of spanning tree database individually. Now what you can do, you can map multiple spanning tree database to a single instance. So in that case, switch will remember only one instance which is covering all the spanning tree database. So in this way, the CPU processing will be reduced. Next thing is port fast. So let's say you are using spanning tree, normal spanning tree. On that switch, you connected a PC or a server, let's say 0 by 1. So this port can take 30 seconds. Listening to learning, learning to forwarding. So this switch, assuming that PC is sending any kind of hello packet, but PC is not sending any hello packet. DPD is sent only through the switches. So it will wait listening to learning, learning to forwarding. So I am waiting unnecessary 30 seconds. So what we can do, we can discard these 30 seconds with the help of port fast. So port fast command used to discard 30 seconds of STP. So what you have to do for this, you have to go to the switch configuration mode, interface fast Ethernet 0 by 1, and here you have to define spanning -tree port fast.
So my understanding is correctly, we're cutting it from 50 seconds to 20 seconds at this point?
No. 50 second is total STP convergence time. So that 50 second is between the switches. When you connect PC, that PC is sending only, will travel through listening to learning, learning to forwarding. That's it.
Oh, okay.
Port fast, always used on host port, host connected ports, or end user port. Clear this thing? Next. Next is BPDU guard. BPDU guard is used to protect one unauthorized BPDU attack. For example, let's say we have this topology, and right now this is my root bridge. Everything is working fine in this topology. Let's say if someone connect their own switch to this existing topology and which is having priority 4096. So I can tell, okay, this is the attacker switch. So if someone decrease the priority of the switch and if it is connecting to the existing topology, so what will happen? It will send the superior BPDU, then that switch can become the root bridge. Right or wrong? Because of the priority. So we have to protect from this kind of attack. BPDU guard apply on port fast port or end user port. Next point here, if any BPDU receive on BPDU guard enable port, port will go to array disable state. Array disable state means that port will not work. So how you will apply, let's say here 0/3. So on switch 3, spanning hyphen tree, BPDU guard enable. Any question on this? Next. If you want to change the priority of the switch, spanning hyphen tree, then VLAN. After that, you have to give the VLAN ID. On which VLAN you want to change the priority. So here I'm taking the default one, which is the VLAN 1 priority and 4096. Always remember, priority can be multiple of 4096 only. If you want to change mode, so by default mode is PVST. This is default. This is RSTP. Clear this thing? Any question here?
I'm sorry, before you close that, I was just reading. Hold on just a second. I'm sorry.
Sure.
Okay, thank you.
Next. STP configuration. STP is enabled by default. No need to enable STP. You can configure it. You can change the priority. You can change the mode, that type of thing. So for example, on switch 1 and switch 2, we have VLAN 10 and VLAN 20. VLAN 10 and VLAN 20. So in the default condition, what will happen? Between switch 1 and switch 2, one switch will be elected as a root bridge. So let's say switch 1 is the root bridge. So switch 1 will do, one link will be active and another link will be standby. So in that case, I am able to utilize only one link, right? in STP, we can utilize only one link by default. That means no load balance. Clear this point? Because the data is sending and receiving through only one link, which is the active. No. But if you want to do the load balancing, can be done manually. How? Let's say I'm on switch 1. So I can define this thing spanning hyphen tree VLAN 10 root primary and spanning hyphen tree VLAN 20 root secondary. If you are on switch number 2, then you can define spanning hyphen tree VLAN 10 root secondary and spanning hyphen tree VLAN 20 root primary. So in this, for the VLAN 10, this switch is the root. For VLAN 20, this switch is the root. So in this way, you can utilize both the links. And this task can be done through this process also.
So out of curiosity then, does that mean that when switch 2 is the route for VLAN 20, is it primarily using the second connection?
Right.
Or the first?
It depends. Like, okay, for which, again, it depends like, okay, what kind of connectivity is there? It is a fast Ethernet or gigabit Ethernet. So normally every switch will select their individual path. For VLAN 10, switch number 1 is the active, which is the root. So it can send data on both the links. For the VLAN 20, switch 2 is root. It can send the data on both the links. Let me explain this thing once again. Hold on. Same way, VLAN 10, 20, 10. So same task you can achieve through this configuration also. Spanning hyphen tree, VLAN 10, priority 4096, spanning hyphen tree, VLAN 20, priority 4, sorry, eight 192.
Sorry, wouldn't that first line be VLAN 20? Or is it?
It doesn't matter. Hold on. Let me complete this thing. See what I'm doing. I'm telling for the switch 1, VLAN 10 priority is lowest. So 4096. So for VLAN 10, this switch is the root because of the lower priority, right? And for VLAN 20 here, this switch is the root because of the lower priority.
Right.
And if you want to verify this thing, you can run show spanning -tree. And show
Sorry,
spanning.
but no. So my question, though, I guess what I'm curious about is I understand how you're making the priority based on the 4096 and whatnot for each VLAN. My question is because switch 2 is
okay, hold on.
I'm trying to figure out how to word this. So you have the two connections, right? And so say the left connection is the one that switch 1 is primarily using, and the right connection would be the redundant connection, correct?
Right.
So then would switch 2 be using the right connection as its primary, or are they both using the left connection as their primary?
Okay, I got your question. So listen one thing. See, let's say forget about 10 and 20. Let's discuss the first basic thing. In STP, if you have multiple paths, in that case, both the switches will run the STP algorithm. And based on those 3 steps, election of root bridge, election of root port, election of root designated port and block port, one link will be active at the time in default condition, right? And I write one more point. In STP by default, there is no load balance. That means only one link will be used in the default condition. Clear this thing? But let's say if you want to need load balancing, means you want to utilize both the links, then that task can be achieved by manual configuration. And that is either you can change the priority or you can define root primary or root secondary. Okay.
Okay, so if you want a load balance, you can use both, but I guess just so I'm understanding the way you have this drawn up, you're still only using that primary connection for both VLANs, correct?
Right.
Okay.
Okay. Now, if you define switch 1 is the root for the VLAN 10, that means those both ports are designated port, right? Because on the root bridge, all ports are designated port, and designated ports are forwarding ports. Clear this thing? So that means those 2 ports are open ports, forwarding ports for the VLAN 10. Clear this thing? Let me clear this thing more. Let's say for VLAN 10. For VLAN 10, this port will be the DP and this port will be the DP for VLAN 10. Let us assume this port is the RP and this port is the block. This I'm talking about, this green color I'm using for VLAN 10. Okay. So if I'm talking about VLAN 10, that will be the configuration, correct or not? Switch 1 is the root. So on the root bridge, both ports are designated port. Between them, one port will be the root port. So let's say this port is the root port and this is block. Clear this thing or not? It's a basic STP function. Correct?
So by default configuration, that would be correct, right? Because you haven't set up.
Okay. So now let's say this 20 now. Now I'm on switch number 2. So for switch number 2, VLAN 20 is the root due to this configuration, right? So this VLAN 20 is telling priority is 4096. That means this switch is the root bridge. So if this is the root, in that case, that port will become DP, that port will become DP, maybe this port will become RP, and this port will become block port.
So based on that, unless you set up load balancing, it's always still going to be on the primary connection.
Right.
Okay.
Now clear?
Sorry, I know that was a long way around to answer my question. I apologize.
No, not an issue. I'm here just to clear your questions.
So if the primary goes down,
If let's say any link goes down, in that case, what will happen? Both the VLAN traffic will shift to the another link.
okay. So everything will adjust accordingly in the standard mode. Okay.
Well, so following up on Daniel's question, if you say you did set up load balancing and the first connection goes down, does that mean it would then default back to standard STP?
Right. So let's say any link goes down, anyone. So both the traffic, both the VLAN tenant traffic will shift to the another link. So that link will carry both the links at that time.
And then once primary is back up, does it shift back?
Yeah. Then it will come to the normal load balancing configuration.
Understood.
So let's do the labs. So for STP, there is for STP there is a discovery number 18. Complete that discovery 18. Discovery number 18.
Understood. Discovery 18. Okay, so right here in this step, it says for delay, but then it says LRN.
LRN means learning state.
It'll
Yeah,
say
but
that for 15 seconds, then it'll change.
Listening to learning. If you again run this command show spanning tree, then one
okay,
can,
so I just missed it.
listening to learning, learning to forwarding. So right now it already came into the forwarding state. That's why you are not seeing this learn state.
Okay. I just saw that mine says LIS.
No. LIS is listening state. Then LRN is learning state. FWD is the forwarding state.
Okay. All right. Thank you. Okay, I'm complete.
Okay. So this is the spanning tree lab. So in switch 1 and switch 2, we have 4 links. Now, due to the STP, only one link be active. If you combine these links with the help of ether channel, switch 1 and switch 2 understand it's a one logical link. So it's a physical topology, but logically switch 1 and switch 2 understand they have connected with a single link logically. So in this you will get redundancy, there will be no loop, and your bandwidth will increase. So how you have to configure ether channel?
Hey, hold on just a second before you move on. So does it prioritize the 4 links in a certain order?
No. Link can be any, but same type link. Yesterday we discussed to form the ether channel, media must be same. Media means your cable must be same, port type must be same, speed must be same, duplex setting must be same, allowed VLAN must be same, and the native VLAN must be same.
Okay, so the physical connections are there, but when you do the ether channel, right, and you have all 4 that are considered one link.
Right. Switch 1 and switch 2 will consider as a logical link, but data will travel through the physical link only.
Okay.
So how you have to configure this thing? Let's say switch 1. So firstly, we'll go to the interface fast Ethernet 0 by. Interface range fast Ethernet 0 by 122. Here you have to define channel hyphen group, any group number, for example like 5. Then you have to define mode, and here mode can be auto, can be desirable, can be active, can be passive. So what protocol will be used, that is based on the mode. So let's say if here I'm giving desirable, so desirable mode is from PAGP mode, so that means I am utilizing now PAGP protocol. Exit this thing, then define interface port hyphen channel, whatever group number you use, and you can define switch port mode trunk and exit. On switch 2, you have to change desirable to auto, rest of the configuration is same. Clear this thing? If you want to verify this thing, you can run the command show ether channel summary. So right now PAGP protocol will work. If I am giving mode active, then LSCP protocol will work. Clear this thing?
I'm sorry, where did channel group 5 come from?
Channel group means we are making a bundle. Channel group represent a bundle, and 5 is any random number. I'm giving that ether channel number 5. You can take any number.
Understood.
So this port channel is discovery number 20. Complete that discovery.
Will do.
Now, FHRP is first hop redundancy protocol. This is also known as gateway redundancy. So for example, okay, how many internet connectivity you have in your company?
How many users?
No. How many service provider connectivity you have?
Oh, one.
Only one? If that service provider goes down, then what will happen?
I'm just assuming we don't handle the internet.
Okay. So normally there will be two or more than two service provider connectivity. So let's say this is your internal network. Now, this is ISP1, ISP2. So let's say these users want to go outside the network on internet or anywhere. So they will firstly go to the service provider and then they will go outside. If I manually put here default gateway .1, so every time my traffic will move to this service provider, right? And after that it will go outside. But assume if this service provider goes down, then what will happen? Will traffic shift to another ISP or not? Yes, Daniel, Craig?
If you have it configured that way, it should switch over.
Okay. But if I manually configure .1, then what will happen?
Then you would not have connectivity if that goes down.
Right. And if I manually put default gateway 2, every time my traffic will move to the ISP2 and ISP2 to outside. And in that case, if ISP2 goes down, in that case, there will be no automatic switchover, correct? So we have some FHRP protocols which is used for gateway redundancy. Gateway redundancy means if my one ISP goes down, automatically the traffic will shift over to another ISP. Getting the point? No.
Now, in that case, are you using completely two different companies?
Yeah.
Or is it a prime and a backup from one company?
It can, if you are taking internet from the same service provider, two linked, right? And if that service provider goes down, both the link will be down, right? So normally we are using two service provider, two different service provider, internet from two service providers. So if one service provider goes down, no issue, we have another one. Clear this point?
Yeah, sounds expensive.
So now FHRP protocol used for gateway redundancy. Under this FHRP is a category. Under this FHRP, there are three protocols. One is HSRP, one is VRRP, and last one is GLBP. Here into the CCNA, we have to just discuss about HSRP. VRRP and GLBP is into the CCNP.
I'm sorry, say that again.
We have to just discuss about HSRP. In HSRP, HSRP This topic is into the CCNA, and rest of the two protocols are in CCNP switch. Whatever is the theory part I will discuss here, but lab I'm not going to show you like VRRP and GLPP. Okay. So first thing, HSRP. HSRP is hot standby routing protocol. Now, first thing, HSRP is Cisco proprietary. It works only on the Cisco routers. One router will be active and another one will be standby. When primary goes down, then standby will become primary. HSRP use multicast address 224.0.0.2 for version 1 and 224.0.0.102 for version 2. HSRP is having two versions, version 1 and version 2. If you configure version 1, then this multicast IP will be used. If you are using version 2, that version IP will be used. HSRP use UDP port 1985. HSRP hello 3 seconds. Hold down 10 seconds. HSRP work on priority. Higher priority router will be active. HSRP virtual MAC this XX is the group number. Preempt disabled. Okay, so understand how this HSRP works. SP1 So now, when you configure HSRP on ISP1 and ISP2, in HSRP you have to define priority to both the service provider. So let's say here I give priority 150 and here I am giving priority 145. So higher the priority, the router will be active. So what will happen? In case of HSRP, HSRP will create a virtual router. This is my virtual router, HSRP virtual router. On that virtual router, we have to define a IP address. Let's say here I give .100 IP address. So that .100 means 10.0.0.100. So on the PC, I will define default gateway 10.100. So what will happen? The user will send traffic to the virtual router. Now, this virtual router will keep track both the ISPs. It will check, okay, who is having the higher priority. Higher priority router will be active. So it is sending hello packet in every 3 seconds. So within 3 seconds, it will get to know who is having the higher priority. So it identify ISP1 is having higher priority, so traffic will move to like this way. Let's say this link goes down. So within 3 seconds, this service provider will get to know this link goes down within 3 seconds. So it will forward traffic to the ISP2 automatically and traffic will go outside. Clear this thing? Any question here?
No, and I'm assuming once the original ISP came back up, then it would default back to the priority.
So that preemption is by default disabled. You have to enable it. So once you enable this preemption, so what will happen? Right now my traffic is moving to the service provider 1, 2. So if again this is back, so what will happen? Within 3 seconds, this virtual router will get to know, okay, ISP1 is now back. So automatically the traffic will shift over to the ISP1 if you enable the preemption. Clear now? That preemption is by default disabled. We have to enable it. So if we enable it, then the fallback happen. Yes, Daniel, Craig, any question here?
Sorry, I'm trying to study the drawing. Just a minute.
Sure.
I think I understand it.
Yes, Daniel.
Yeah, I mean, outside of knowing how to enable preemption and setting up the VR in the middle, I mean.
Okay. Now one more thing. This HSRP is working inside the network in this lower network, internal network. But if this link goes down, that outside link, then what will happen? Will HSRP will work or not?
Well, what work? I'm sorry.
I didn't hear that question either.
See, previously we are talking about this lower link, which is connected to my switch, right? Previously I am discussing this link. If this link goes down, then traffic will shift to another ISP. But it can be a reason this outside network goes down, outside link goes down. Then if this link goes down, what will happen?
Well, it shifts.
Well, sorry, go ahead, Daniel.
Yeah, it shifts over, right? So obviously the priority level is not necessary any longer. It switches over to 145, the ISP2. It's the same question that you just discussed, right? It would follow the pink going over to .2.
No. If this link goes down, HSRP will not work because HSRP is working inside the network, right? If this link goes down, what will happen? The traffic will
Are you talking?
Traffic will go to the virtual router. Virtual router will check, okay, both the ISPs are working fine, means this link and this link is working fine. And who is having higher priority? ISP1 is having higher priority. So traffic will be on ISP2. Now ISP2 is unable to forward that request to the external world. So what will happen? The packet will drop here.
So which path are you talking about not working?
Well, so if I understand correctly, what you're saying is it's the data is still going to the virtual router.
Yes.
And then so it's trying to still travel through ISP1 because that's the primary.
Right.
And the link between ISP1 and the outside world is down, so it's just going to be hitting that router and dropping packets because there's nowhere for the data to go.
Right. So what we have to do, what is the solution for that? You can track this interface also. You can track this interface in your HSRP and you can call that tracking inside the HSRP. So you can implement a policy like this way. If this link is up, then forward the traffic to external world. Means with the HSRP, you have to check this link also, outside link also. If this link is up, then forward the traffic to the primary one. But let's say if this link goes down, then what you have to do, you have to decrease priority. Decrease priority from the originally configured value. So by default, if this link goes down, it will decrease -10. So if it decrease -10, what will be happening? 140. Here how much? 150. Now it can travel to the ISP2.
Now, is that a manual configuration or does it automatically happen?
No, it's a manual configuration. You have to do the configuration.
So basically somebody has to be sitting there watching the network to see that that link is down to make that configuration change in order for the traffic to properly travel outside.
Right.
Okay.
Can you set that tracking identification? I can't remember. Sorry, there's a lot going on here that you. Does that say track identification?
Track that interface. I will show you that complete lab.
Yeah. So the track interface, does that have like a call home to or notification going out, or like Kirk said, does it physically watch?
It's a like functionality in HSRP. We can track a particular interface, so that if outside link goes down, then change the path according to the priority which is configured on the device. Let me show you the lab.
Oh, okay, so just to understand then, do you pre-configure that so it happens automatically, or do you have to do it real time?
We have to do in real time. We have to configure this thing. All these parameters we have to configure. We have to define the virtual router IP address. We have to define the priority. We have to define which interface we are tracking.
So then somebody has to be sitting there watching that link to make sure that it's active, and if it goes down, they have to manually configure everything at that time?
No need to configure at that time. Everything is configured when you are configuring HSRP at that
Okay,
time.
so that was my question. So you're pre-configuring all this so that
Right.
if that link goes down, the router knows to switch over to the other
Yeah, that is pre-configured.
ISP.
Yeah.
Okay, so that was my question. I didn't know if somebody had to be sitting there watching the links.
No.
Yeah, so you preemptively set this up so that it decreases priority so that it can have full redundancy.
Sure.
Okay.
So this is the HSRP. Let's discuss the property of VRRP and GLBP, and then we'll do this lab. VRRP. Virtual router redundancy protocol. Virtual router redundancy protocol. VRRP is open standard. One router will be master and another one will be backup. Work on priority. Same way, higher the priority, router will be the master. It use UDP port 112. Hello time 1 second. Use multicast address 224.0.0.18. Here preemption is by default enable here. It use virtual MAC. Then again XX is the group number. So whatever group number you use, that will be here.
Sorry, is that 5 echo 00?
5E00.01XX. So whenever
Okay, so
yeah,
it'll always be that number with the last two numbers being the group number.
right.
Okay.
HSRP and VRRP doesn't provide load balance by default. Doesn't provide by default load balancing. The meaning is at a time only one service provider will be active and the another one will be into the standby. Now last one is GLBP. GLBP is Gateway Load Balancing Protocol. Gateway Load Balancing Protocol. Now, GLBP working is a little bit different. So firstly, discuss the property, then we'll see how it works. So again, GLBP is Cisco proprietary. It uses multicast address 224.0.0.102. Hello interval 3 seconds. Hold down 10 seconds. It work on priority. Higher priority router will be AVG. AVG is Active Virtual Gateway. And rest will be AVF, Active Virtual Forwarder. Virtual MAC will be group number. By default, provide load balance. By default, provide load balance. So the router which is having the higher priority, that will become AVG, Active Virtual Gateway. It's like a manager. So what will happen if the users are sending traffic? So firstly, traffic will move to the AVG router. It will check which AVF is free, Active Virtual Forwarder, who is free. So let's say it identify ISP2 is free, so it will forward the request to the external world. Now let's say user 2 is sending the traffic. Again the traffic will go to the service provider, AVG router. AVG will check ISP2 is busy, so it will forward the traffic to the ISP3. Let's say next request is coming and it will identify, okay, ISP2 and ISP3 are busy, so it will forward the request to the next ISP and the traffic will go outside. Let's say all three ISPs are busy, and if it receive any new request, so it can send the traffic to ISP1 also, like this way. So in this way it provide the load balancing, means it can distribute the load among the service provider. Clear this thing?
Yeah, so basically a round robin.
Right. let's say we have this network. Inside the network, we have network 10. Here we have network 12. This server is having IP address 200.200. So we have this type of network. So on this, I have .1 IP address. Here I have .2. So let's configure this thing. Let's say this router is my internet router. So one interface is connected to the server. So interface fast Ethernet 1/0. IP address 200.200.200.1. After that, interface fast Ethernet 0/0, which is connected to the ISP1. So let's say IP address 12.0.2. Interface fast Ethernet 0/1. IP address 13.0.0.2. So we configure all these IP address. For the HSRP, we need end-to-end communication also. So for that end-to-end communication, what I'm going to do, I'm enabling the routing. So here I'm enabling router EIGRP. You can use any routing protocol. ISP1.
What was the WR command you put in?
WR is the short form of write memory. For the saving the configuration, either you can use copy run start or you can use write memory. But in the exam, you have to use only copy run start. Don't use WR command in the exam. WR is write memory for saving the configuration. ISP2. So adjacency form, that means EIGRP protocol is working fine here. So now we have to configure the IP address on the systems.
Is there a way in this packet tracer to make it not so combined, to spread things out a little bit? Where you can see all the names?
Sorry?
In the packet tracer.
Yeah, in the packet tracer.
Yeah. Is there a way to make things a little clearer? Like down at the very bottom where everything's where it doesn't overlap?
No.
Okay.
So
I have a question, and I don't know if I just saw something wrong or I'm just confused. For both the routers that you have listed as ISP1 and ISP2,
right.
Did you configure both the FA00s on both of those to be 10.0.0.1?
No. .2 I configured here. It is showing neighborship. It formed the neighborship with the ISP1.
No, but when you set the actual IP address, I thought you did
No, no, no.
Oh, okay.
So let's say here I put dot one. Okay. So once I configure the IP address everywhere. In this case, I just configured gateway 1.1. So let's verify this thing. Can I communicate to my server? Okay, first packet will drop and now you are able to communicate. Okay. So my routing is working fine. But let's assume ISP1 interface fast Ethernet 0x0. If this link goes down, then what will happen? Previously it is pinging. Now the traffic will not switch over because we haven't configured any HSRP right now. So let's first configure HSRP. Okay. So to configure HSRP, you have to go to the interface fast Ethernet 0x0, which is connected to your internal network. After that, there is a command standby. Standby, then any group number. So group number, let's say here I am taking 2. Then IP. This IP is virtual IP address. So let's say 10.0.0.100. Enter. The next command, standby 2 priority. So let's say here I am giving priority 150. The next command, standby 2 preempt. Okay. If you want to put the tracking on that particular interface, you can put, let's say, in same way interface fast Ethernet 0x0. Inside that there is a command standby to track fast Ethernet 0 by 1. Do show history. So to configure HSRP, I run all these commands.
So you just made ISP1 the standby, or
No,
you're
no,
putting
no.
the standby command on that one, so if it goes down, it'll switch over to the other one.
Standby keyword is for HSRP basically.
So this is enabling HSRP to where if it fails, it can kick over to the other router.
Right.
Okay.
Same type of configuration you have to do on service provider 2. Interface fast Ethernet 0 by 0. Standby same group number 10.0.0.100. Virtual IP will be same. Standby 2 IP address. Then standby to priority, let's say here 145. Standby to preempt. And exit. So that will be the configuration of HSRP. Yes. So this is my virtual router. So I define this virtual IP on both the service provider who is my virtual router. Then I define the priority, enabling the preempt, and on the service provider 1, I define the tracking. So that means track this interface also. After that, on the client machine, what you have to do, you have to configure default gateway as 100, your virtual router IP address. Once you configure this, previously that is not communicating. Now let's verify. It is communicating right now. If you want to check on which ISP it is going, so you can use a command tracer. So it is showing, firstly it went to the 10.0.1, which is the ISP1, and then it is moving to the 12.2, which is the internet router, and then it is going outside. Clear this thing? Now, some more verification. Let's say I'm on ISP1. There is a command, show standby. So if you run show standby, you will get You configure the group number 2. State is active. This is the virtual IP address. Active virtual gateway. See the last 2 digits. It's XX. So I configure group 2. So that's why 02. Hello and hold down time. Who is your standby router? How much priority you configure, and you enable the tracking on that particular interface, and it is showing state is up, and if state is down, in that case it will decrement the value 10. One more command, show standby brief. So it is showing you configured priority value 150, preemption is enabled, your state is active. Active is the local router, who is your standby, and which is your virtual IP address. Same type of command if I run here.
So
Yes.
so does that mean that your secondary priority level has to be within 10 of your primary?
No,
So
it's not mandatory.
it's not what?
It's not mandatory. You can
Right.
take
It's
any
going to
value.
decrement. It's going to decrement by 10, right? So if you
By
had it at
by default, it is decrement by 10. Actually, this is the packet tracer. It's a software. But if you have actual router, in that case, you can define any decrement value. This is a software limitation basically. But in the actual production router, you can put any decrement value.
So if you had multiple routers, you could have the decrement by 1 for each router?
Right, you can do that thing. Okay, so let's verify this tracking also. Let's
And
say,
then,
yeah.
sorry,
Okay.
one last question. You would have to go into each of the PCs and change the gateway to the virtual router, correct?
Right. Correct.
Okay.
Then only it will switch over, na? Because now the PC knows virtual router is 100. So every time the traffic will move to the virtual router, that virtual router will keep track, is sending hello packet in every 3 seconds to both the service providers to verify all the links are active or not. So let's say I'm on ISP1. If I shut down the external link, which is going outside, let's say if this link goes down, shut down. This link is down. Let's try once again. I'm able to communicate or not. I'm still able to communicate. And see, it automatically switch over the traffic to the ISP number 2. Clear? 10.2 is the service provider 2.
Yes, and then what happens if your secondary is not within the decrement value of 10 at this point? So what if it was 135? Does it just take longer to get there?
No, if it is okay. No, in that case, the traffic will switch over to the primary also, primary only. It will not shift to the secondary, because every time it is showing priority is 150, 140 is here. So virtual router will forward that traffic to the ISP 1 only. In that case, your traffic will drop. So you have to check the configuration. Okay, whatever priority you configure there on ISP 2, you have to check the configuration, that thing also.
It does have to fall in within the value.
Right.
Okay, understood.
So now preemption is, we enable the preemption. So again, if I enable that interface, so interface is enabled. Still I am able to ping. Clear now? Again it switch over to ISP1. Any question here in this lab?
No, none at this time. You said this is on the actual exam?
No, that HSRP will not come into the exam.
Can you do a print screen of this and put it into one of those paint slides?
Sure. And now?
Thank you.
So there is a discovery number 24. So try to complete the discovery 24. If any incident happen on your devices, then send me a log message, a alert message on a centralized server, which is my syslog server. Clear? So for example, right now we have this topology, which is pre-configured. So for that task, you need a separate PC. Okay, let's say in this I have Windows, any operating system. In this you have to install the syslog server. Syslog server is that it's a third-party tool. You can download, you can purchase the operating system, and you can install in Windows or Linux operating system. So let's say this is my 10.0.0.150. So we can configure this thing. If any incident happen into the network, then send a log message to the syslog server, so that the person who is monitoring this syslog server, he will identify, okay, there is a issue between ISP1 and internet router, or there is a issue in ISP2 and internet router. So syslog used for centralized logs and alert messages. Logs and alert messages. Syslog work on UDP port, .514. Syslog work on security levels. syslog security. Emergency, alert, critical, error, warning, notice or notification, information, or debug. So emergency 0, alert 1, critical 2, error 3, warning 4, notice 5, 6, and 7. So how you will configure on the devices, either on the router or on switch, on every device, what you have to do, that's on R1. First thing you have to define logging on. Once you run this command, syslog service will be enabled on the device. Then you have to define logging host and the IP address of the syslog server, for example, like 10.0.150. Then you have to define logging trap and let's say 7, or you can type debug. So 7 means, or debugging means, it will give all the messages, all kind of messages. But let's say if you are doing this thing, trap and trap 4, so it will give messages for 4, 3, 2, 1, and 0. It will not give 5 and 6, 7. No.
Okay, so I'm sorry.
Yeah.
Trap is the security level?
Trap, and then you have to give the security level. Either you can write the complete like emergency or alert. Otherwise, you can write here like say trap 7, trap 4, trap 3. So trap means these levels.
So those are predetermined numbers for the syslog security level on the left side of your diagram.
Right.
Okay. Are those Cisco proprietary, or are they like that across the board?
No. This syslog is an open standard thing. You have to purchase the software. So we have PRTG software is there, Negios software is there, and one is Kiwi syslog is there. So these are the third-party application you have to install in any operating system. For example, we have this network which is working fine right now. So what we can do in the same network, here in this software, in the services, there is a syslog option. And by default, this syslog service is started. And you can see there is no messages right now. Clear? So you can assume this thing. This is the PC, Windows PC. In that PC, I install the syslog service or syslog software. So once you install the syslog software, then it will become the syslog server. Right? So now you have to configure all these devices. So let's say on R1, logging on, logging host, logging trap, and let's say debug. I run these commands. So we have to run these commands on all the 3 routers. So let's say is
So is it debug or debugging?
debugging.
Okay.
Okay, so I define. So let's see, is there any messages here or not? You can see there are some messages, EIGRP messages. And why we are receiving these messages? Because of the adjacency. So something is happening into the network, that's why we are receiving all those messages. So you can see. One more verification you can do. Let's say I shut down that interface. The interface is down. Then after that, again I run no shutdown. See. Line protocol down. Then it is giving the message like, okay, because that interface is down, so my HSRP is running already there. So the state again change, standby. And once it again up, then everything is working fine. So anything happened to the network, it will send a alert message to the centralized server. This is your syslog. And remember this thing, on this syslog topic, there will be 2 or 3 questions in your exam. I think so maximum 3 questions will be there. And those are multiple choice question. And in multiple choice question, there are approximate 3 answers you have to check. Means you have to select best 3 options in most of the things. So you have to remember this correct order, and you have to remember like, okay, this emergency is 0, alert is 1, critical is 2, error is 3, warning is 4, notice is 5, information 6, and debugging is 7. So if you enable warning, then you will receive warning, error, critical, alert, and emergency. Clear? Any question here?
None from me.
None for me either.
Okay. So there is a activity discovery number 52. Complete that activity.
What number?
52.
52.
Yeah.
I'm sorry, you said the port will go into what under violation?
Yes, error disable state. Okay, once again.
Oh, error disable?
Yes.
Okay.
So once again, that switch port security is used to reserve a port for the particular user or for a particular MAC address. We have to implement switch port security on those ports which are connecting with the users. Next point, how to configure it. You have to enter into the interface and then you have to define first command switch port mode access because that port is a access port. Second command switch port security. This command is important. You have to enter this command first. Switch port security. This command will enable the port security on that particular interface. Then you have to define how many MAC address you want to allow on that particular port. Then switch port security maximum 1. Maximum 1 means only one user is allowed and you have to define that MAC address. So switch port security MAC address, let's say AAA. This is the MAC address. Either you can use particular MAC address or you can define sticky. Sticky means first come first. So whatever user will connect firstly to that port, that MAC address will automatically stick. Then you have to define an action. Switch port security violation shutdown. So if any violation happen, the port will be shut down. Shutdown means that port will go to the error disable state. If the port is into error disable state, that port will not work. And
So,
yeah.
I'm sorry. I guess I'm curious, what would be the reason why you would use the sticky command? Because it seems like that would just bypass the security if the first person to connect is somebody you didn't want connecting to that switch port.
Right. That is an option. But normally recommendation is you have to go with the particular MAC address.
Okay, that makes sense.
Now, if you put the shutdown, in that case, what will happen? Port is shut down and one log and alert message will travel to the syslog server. If you put restrict, in the restrict, the port will be down. That will not go to the error disable state. The port will be down and one log message will travel to the alert syslog server. In protect, the port is down, but there will be no alert message. So recommendation is always shut down. Clear this thing? For this, we have a discovery number 37. Try to perform that activity. 37. Discovery number 37. Getting the error.
Kirk, are you still in the interface? Maybe you need to hit in.
No, I already closed out of the lab, but when I tried doing that, it came up and I hit enter and it asked me, I guess, for a name for the configuration, and no matter what I typed, it said it was invalid.
Can you show me that thing? You can start the lab once again and show me where is the issue. Because we have one more day and we have to rectify each and every problem.
I have mine up, Kirk. Hold on. I'll share mine.
Yeah, sure. Yes.
So it's down for hang on. So go up.
Well, I mean, I should be able to do it here, right?
It's going to be on, hang on, keep going up real quick. Let me see something. Hang on, let me open the, this is 37, right? Let me open the PDF file real quick.
Rakesh, whenever you do that, I mean, you can save your running config wherever you're at, right?
if you are into privilege mode, then copy run start command will work. Type here copy run start anywhere.
Oh, it was task 1. It was the first step.
Yes.
What was it?
So
Copy space run space start.
I'm sorry, say it one more time. Copy.
Run space start.
I don't think you have to name it, Kirk. I think it's just confirming that that's exactly what you want to do.
oh, okay, that's where I was messing up. I was trying to give it a name.
Yeah, right there. I sat there and stared at that for a while thinking what I needed to name it, and then I hit enter and it followed instructions. Just like it is now, configuration.
So if you are into privilege mode, you can run this command copy space run space start. Let's say if you are in configuration mode, go to the configuration mode once. Okay, try here copy run start. That command will not work. Copy run start. This command will not work. Why? Because this command is for the privilege mode. If you want to run any privilege mode command into the configuration mode, then you have to use do space copy space run space start. Do copy run space start, enter. Clear this thing now? Any confusion?
No, that makes sense.
Okay, so now this is the task number 1. Go down this PDF down. So they are enabling here sticky. If you want to change MAC address, you can change it. Okay, go ahead, down.
Yeah, then they have you bring it down to
Now hold on.
error.
So now if a port is into the error disable, there are 2 options to recover that port. Okay, so on the switch number 1, exit from there, type here show interface status command. Enter. No. Interface status, enter. So if any link will be in, any interface will be in error disable state, so that will be showing here. Right now it is showing Ethernet 0x1 link connected to the PC connected, and there is no error disable, because I think so when you are doing the lab you remove that thing. Okay, so
Yes.
there are 2 methods. One, if a port is into error disable state, you can do firstly completely shut down that interface and then run no shutdown command, then it will work.
Yeah, that's what I did.
Second method is a automatic method, automatic recovery. So for that there is a command error disable recovery cause p secure volition. P secure volition is for the port security. There are lots of reasons through which a port can go into the error disable state. For example, BPDU guard, loop guard, port security. So these are some reasons through which a port can go into the error disable state. So if you know the reason, then you can type error disable recovery cause P secure volition BPDU guard like this way. Let's say if you don't know the reason, in that case you can write error disable recovery cause all for any reason. Then error disable recovery interval 30. This 30 is 30 second. This timer you can change. So after 30 second, that switch will automatically try to reattempt to recover that port. Clear this thing? Any question here? Craig, Daniel?
No, not at this time. That makes sense. That there's a specific command to do it.
So that port security is for your reference. Port security question will be not in the exam. But
Well, will not. Say that
multiple
again.
choice question will be there. Yes.
I'm sorry. Say that again.
Port security lab will be not in the exam, but port security multiple choice question will be there.
Right.
So whatever labs I'm telling you, you have to go with that lab. Exactly same kind of lab will be there, but you need practice. And lab is having the highest weightage. So if your lab is correct, then passing of the exam is chances are very high.
Thanks, Rakesh. No pressure.
Okay.
Come on, Rakesh. I'm gonna make you laugh.
Not issue. Anytime. Okay. After this training, also you have my email ID. Anytime, whenever, let's say if you are trying to give exam after 1 month or 2 months, you just drop me an email. Okay. So whatever is the updated information regarding the exam, maybe some questions are changed, maybe some questions are updated, I can share that information. Okay. So shall we take a lunch break, or we'll continue after, we'll take after 1 hour?
No, that sounds good. I'm down for lunch.
Okay. So we'll meet after same 45 minutes.
Okay.
Sure.
1:15.
Sure. Daniel, are you there?
Yes, I'm here.
So our next topic is NTP. NTP is Network Time Protocol. NTP is used to synchronize the time. NTP work on UDP port number 123. In the network, all devices time must be synchronized in case if you are implementing any kind of authentication. So NTP use stratum to describe the distance between network device and an authorized time source. So stratum value is used basically to define who is your primary NTP server and who is your secondary NTP server. Stratum 1 time server is directly attached to an authorized time resource. Stratum 2 NTP server receive its time through NTP from Stratum 1. So basically, the stratum value is used to define like who is your primary and who is your secondary. If you want to configure NTP, so let's say we have this thing. Let's say this is my R2, this is my R1. So on R2, you will define NTP master. And let's say 2. NTP master 2 means I'm defining stratum value 2. Then on R1, let's say this is having 12.0.2 and this is 12.0.0.1. So on client side, on R1, you have to define NTP server and the server IP 12.0.0.2. Make sure NTP server IP must be reachable. If that is reachable, in that case, your time will be synchronized. And on R1, you can check out through show NTP status and show NTP associations. Clear this thing. So on the R1, what you have to do? On R2, you have to configure the time, configure the clock with the help of clock set command. So let's say you want to synchronize the time through R2 on all the devices. So what you have to do? On R1 or R3 or any other routers, you have to define like who is your NTP server and make sure that 12.2 must be reachable. That's it. So on NTP, there is a discovery number 38. Try to perform that activity. 38.
Got it. Okay, that's done.
It's done.
Yes.
Next is switch port analyzer, or I can say span. Switch port analyzer. Span is used to monitor traffic on particular port. Let us assume we have this switch. On that switch, there are two PCs, and 0 by 1 and on 0 by 2. So in span, what you can do, you can define the particular traffic on the particular port. So for example, if you want to know what kind of traffic is moving through this port and through this port, so what you can do, you can implement span. In span, source and destination will be on same switch. So for example here, if I want to monitor the traffic on 0 by 1 and 0 by 2, so these ports are my source port. And if I want to forward that traffic to this particular destination, so my destination will be port number 0 by 24. So to implement this, you can define monitor space session ID, source, then interface, and the name of the interface, for example 0 by 1. And after that, you can define both. Both means incoming and outgoing traffic both. Same way you can define monitor session 1, source, fast Ethernet 0 by 2, and here again both. If you want to define particular receiving and or outgoing traffic, so what you can do here, instead of both, you can type RX or TX. Then you can define a destination. So monitor session 1, destination 0 by 24. There will be interface, fast Ethernet 0 by 24. Clear this thing?
So does the word interface need to be in there between source and the Ethernet port?
Right.
Okay, I wasn't sure if you were just noting that it was interface or if you actually have to write interface.
Yes. So this is the span. One more is there, one advanced thing is there, which is into CCNP RSPAN, remote span. In remote span, your source is on one switch and destination can be on any other switch. That is the RSPAN, remote span. So to implement span, firstly let me check the span command will work here or not. It's working here. So for implementing span, we need a analyzer. So for that, there is a sniffer. That sniffer is having capability of capturing the packet. So let's say
Does that actually have to be a piece of hardware, or can it be a computer running sniffer software?
a PC running sniffer software. For example, like you have Windows, and on that Windows you are running Wireshark or Ethereal, any packet capturing tool.
Right, so it's not an actual piece of hardware then?
Right.
Okay.
So this I connected on port number 24. So let's see now. So right now it starts receiving the packet of STP. Why STP and CDP? Because it's a switch. So switch is sending CDP and STP packet continuously. So you can see it is receiving the EIGRP packet also. In this topology we configure what? HSRP. So it is receiving the HSRP packet also. So now what I'm going to do, I'm implementing span here right now. Monitor, session ID, source, interface. Let's say fast Ethernet 0/3. Both. Same way. Four. Now, so here you can, here I'm defining the particular interface, but if you want to define a particular VLAN, you can define that particular VLAN also. For example, Here you are giving source VLAN 10. So it will automatically detect VLAN 10 interfaces as a source. After that, destination is fast Ethernet interface, fast Ethernet 0x24. Okay. So now I'm sending some kind of traffic on that particular port. For example, like I send the ping command. Maybe there is some issue into the internal network, that's why the traffic is not reaching there. Not an issue. But we can ping 10.0.0.1 at least. Yes, 10.10.1 is reachable. My gateway is reachable. Let's say 10.2. This is also pinging. Let's say what I gave here 150. HTTP 10.0.0.150. So HTTP is also working. So I sent some traffic through this port number 0x3. Let's see all the packets are here or not. You can see ISMP packets are there. Syslog packets are there. See this HTTP packet. We send the request for HTTP. There will be a source IP 10.2. So it is receiving all the interfaces. Sorry, whatever interface we configure as a monitor interface, it will receive all the packets. So here this sniffer is not that much good because they've done some programming. Otherwise, if you use any Wireshark or anything like Ethereal, in that case, you will get the complete information about the packet which is moving through that interface. Clear this thing? So you have to just define what is the source and what is the destination. And whatever destination port you define, through that port you cannot send any other kind of data. Means if you are sending any ping or any other thing, that will not work. That particular destination port is only reserved for receiving the packet. Clear? Any question on spam?
No, not at this time.
Okay. So next will be DHCP snooping. Now, DHCP snooping. Let us assume this is my DHCP server, which is connected with this switch, and these are my client. So all these PC are receiving the IP address from this DHCP server. Everything is working fine. Let's say if someone connect a wrong DHCP server, or you can say attacker DHCP. Right now, this DHCP server is providing you IP address from the network 10. And your all the services, internet, printer, internal resources, everything is running on network 10. And this attacker DHCP is configured on network 20. So if those two DHCP server are connected through your network, then your client will get IP address from which DHCP server? Any idea? If I connect two DHCP server into the network, then my client will get IP address from which DHCP server?
Well, it would be from whichever gateway it's configured to.
No. See, DHCP always provide first come first service. So the client can get IP address from any DHCP server in that case. So if my client will get IP address from this attacker DHCP server, so in that case they will not able to access my resources, they will not able to access my services because services are configured on network 10. So if you want to prevent this kind of attack, you can implement DHCP snooping. So DHCP snooping is used to protect from unauthorized DHCP server. If you enable DHCP snooping on switch, all switch port will become untrusted, and on untrusted port DHCP offer packet is not allowed. Because when the server will provide first communication, they will send DHCP offer packet. But DHCP snooping is enabled here. So this port and this port will become untrusted. Where correct DHCP connected, you have to make that port as a trusted port. You have to make that port as a trusted port. So manually you have to make this port as a trusted. If you make trusted, in that case what will happen? It will allow DHCP offer packet, and this client will get IP address from that DHCP server. Clear this thing? In DHCP snooping, switch maintain a snooping database which contain all information about DHCP assigned IP. So it will maintain the IP address database basically. So it maintain that entry. Okay, port number 0/2 receive a IP address from this DHCP server, and what will be the MAC address. So it maintain the complete database. So to configure DHCP snooping, your first command will be IP DHCP snooping. So this command will enable the DHCP snooping on the device. After that, you can define IP DHCP snooping VLAN and the particular VLAN. Let's say VLAN 10. Any ID in which you want to enable the DHCP snooping. Then interface fast Ethernet 0/1.
Do you have to bracket it like that?
No.
Okay.
IP DHCP snooping test. That will be the configuration.
Does that say IP DHCP snooping trust?
Yes, trust.
Okay.
So now, if you configure this, so the client will get IP address from that DHCP server, and this switch will maintain a database, snooping database. In that snooping database, there is an entry what IP address received by the DHCP server and what is the MAC address of the EC. So that will be into the complete database, and that database is on the switch. Clear this thing?
Yeah, that makes sense.
With With the DHCP snooping, there is one more topic which is related to the DHCP snooping, IP source guard. IP source guard. In IP source guard, basically IP source guard also used DHCP snooping concept. So firstly, you have to configure DHCP snooping. Through DHCP snooping, it will maintain a database. Once the database is created, then you can implement IP source guard on that. In IP source guard, once you configure the IP source guard, it will check the IP addressing also. Let's say you receive a IP address from the DHCP server 10.0.0.2 and you change the IP address manually and you are sending any request. So firstly, the request will go to the switch. Then this switch will check that request with the help of DHCP snooping database. If that IP address match to my database, then only the request will go forward. Otherwise, the packet will drop there. Clear this thing? So IP source guard used to prevent IP snooping. It worked with DHCP snooping. So let's say 0 by 2, 0 by 3, 0 by 4, 0 by 5. So this is the DHCP snooping. Once you configure this, after that, let's say interface range fast Ethernet 0 by 2 to 5. Here you can define IP verify source and exit. That's it. So now what will happen? Once you configure DHCP snooping, this switch is maintaining a DHCP database. Let's say A, B, C, D. So this is my DHCP snooping database. Okay. So if you are configuring IP source guard on that, so it will check this IP addressing. So let's say this client is having 10.0.2 IP address, which is provided by this DHCP server. And let's say if it is changed 10.0.0. let's say 10, it changed the IP address. So what will happen? It is sending any request to anyone. Let's say it pinging, HTTP, any request. So whenever it sends the traffic will reach to the port number 0 by 2. There will be the interface information also. This one. So this switch will receive the traffic from MAC address A, according to the database, it should be 2, but the request is coming from 10. So that traffic is not matching my database. So this request will drop here automatically. Clear this thing? Any confusion?
No, I think that makes sense.
So these two features will work together.
Is there any concern with the type of switch?
No.
Here's what I found on the web for any of you.
And is that a proprietary thing to Cisco?
No.
Okay.
If you go with any other vendor, concept will be same, but the commands like syntax will be changed. Next topic is remote authentication. Remote authentication. If you remember, when we are configuring telnet and SSH, we are creating the username and password on the local on the switch and on the router. Clear? We are creating the username via username command. Clear? So that means that particular user is present on the local on the device. But into the production environment, always the username and password will be on some authentication server. For example, when you log in your company, there will be a domain user account, right? Or you are logging with a local user account. How you log in your laptop?
With a smart card?
With a smart card, right? That smart card is providing you remote authentication. When you connect with a smart card, you are giving the username and password, right?
Correct.
So where is that username and password? That is on local on the system or somewhere else?
Oh, that's a good question. I think it's in a database stored. Well, there's local certificates on the machine that talk to your smart card as you put it in, so they have to be locally there.
No.
So there was also a server.
Yes.
The certificate is on the smart card.
But I think they're also on the server, aren't they, Kurt?
That's like
And access and stuff of that nature.
Well, for 2FA, you have the certificate on the smart card, and then you also have to enter in a second authentication, but it's authenticating through well, as far as our laptops go, it's all local.
no. Whenever you are connecting your network, that authentication will be remote always. If you log in with a local user account, then you will not able to access your resources. Okay, for example, somewhere you are connecting with the nasa.gov and
Yeah. So like Pulse, there's a VPN access that gets us on the network.
exactly. So whenever you are connecting with the VPN or some other things, then you are giving the remote authentication to your device. Then only you are able to connect with your server and your connect networks. So for that, there is a AAA. AAA is authentication, authorization, and accounting. Any idea about authentication? What is authentication?
Are you talking about as in how you authenticate?
Yes. What is the normal meaning of authentication basically?
Proving a password that you've set up initially?
Right. So that means you are telling your identity basically. Right?
Right.
So in simple way, I can write, who are you? What is your identity? Then authorization. Authorization means what you can do. And last one, accounting. What is the meaning of accounting?
I'm not sure what accounting would be, the short definition.
Accounting means what you did. So for example, whenever you connect with the
What you're accounting for. Okay. Yeah, that makes sense.
whenever you connect with the VPN, so is there any monitoring what you are doing? Can someone monitor you? Like if you are connecting with the network and whatever changes you are doing into the network, so maybe there is a monitoring system who is monitoring you, right or wrong?
It's our network folks that can monitor us.
Okay, you have a smart card. Can you do any modification through that smart card? Means you have full privileges?
No.
No. Right? And maybe the Crick is having that smart card. Crick is having the different right. Daniel is having different rights. Correct? Is it possible? Right?
That is correct.
Then how we are defining that thing? We are creating a user and we are creating a profile of that user. And we are mapping certain tasks, certain command with that profile, and we are attaching that profile with the user. This kind of task can be done with the help of remote authentication server. And those remote authentication servers are Radius server or Ccna server. In Cisco, we are using these two things, Ccna server or Radius server. Somewhere we are using LDAP authentication also with the Microsoft. That is also possible. So let me give you a basic example of this. On this R1, I configure telnet. If I configure telnet, and here I create user. Let's say test1. Test1 is the name of the user. And these are the PC, PC1, PC2, PC3. If I write the basic configuration of telnet, so what will be the configuration on R1? You will create a username, let's say test1, then you define privilege 15, and then define password, let's say 123. After that, you are defining line VTY 04 and login local. If I configure this thing, this telnet configuration, meaning of this configuration is you can take telnet, but through this local user account, and that local user account is configured where? Created where? On the router. Clear this thing?
In your configuration write out that says username test1, is that 10, 15?
Privilege.
PRI?
Yeah, PR privilege, because space is less now, that's why I write small. It's a privilege. There is a command, username, the name of the user, then privilege level 15, then password, and then 123. Not getting? Yes, Daniel. Should I write the complete command?
No, that's fine.
Okay.
I was just making sure that I understood what you wrote out there.
Okay. So now, if you want to put a remote authentication, so that for that, let's say this is my remote server. Remote authentication server. So whenever we configure a remote authentication server, in Cisco we have Cisco ACS, access control system, okay, and ICE. These are the two servers through which you can implement remote authentication. So when you configure these servers, then you are defining two protocols. Either you will configure radius or you will configure TACAS. These are the two protocols, radius and TACAS. So whenever you configure radius and TACAS server, there will be IP address. For example, like whenever you configure this, there is a IP address, for example, like 10.10. Let's say 100, and there is a key 1 2 3 4. So whenever you want to implement remote authentication, then you have to tell your device who is the radius server. Means you have to give the radius server information. Here you have to tell radius or TACAS IP and the key. So once you give this thing, your device will authenticate with server, and then whatever user account created here, you can use those user account to log in. Read it carefully. If you have any question, then ask.
The only question I have is, what is the line VTY again?
Line VTY, whenever you configure telnet or SSH, these are the virtual line. To
Oh,
access
that's right. That's right. That's the protocol. Okay.
Clear this thing?
I believe so.
It's not clear, then not an issue. In the next slide, everything will be clear. Okay. So I'm going to configure this time authentication via Takash server. So here is my Takash server. So let's say here IP address is 10.0.0.10. This is my R1. So you have to make this Takash server. Okay, how to create this Takash server, that is not our part. That is the task of the security team. So on R1, username. Let's say I create a username Rakesh. Privilege 15. Password 123. Now, after that, Takash server, then host, and then you have to define what is the IP address of the Takash server. Then you have to define a key. Let's say 1, 2, 3, 4. That IP and the key must be matched on the Takash server. After that, you have to define AAA new model. So once you configure AAA new model, AAA feature will be enabled on the router. After that, AAA authentication login default group Takash and then local. So what is the meaning of this command? AAA authentication login default group Takash. Firstly, if authentication asks, then firstly it will check the TACAS database, TACAS user account. If the TACAS is unreachable, then you can log in with the local user account, which is Rakesh. So here I am creating a user. So after that, let's say line VTY04, you can define login, authentication, default, and exit. This default is this default group. So I just assign IP address on that fast Ethernet which is connecting to my network. After that, I am creating a user account, username Rakesh, privilege 15, password 123. So that is the local user account. So if you go into the server, so I assign IP address here 100. Let's say 10. If you go into the services, there is a AAA. So in that AAA, client name, let's say this router, host name R1. So client name is, let's say, R1. Client IP is, let's say, 10.0.1. I'm creating that database basically. Secret key, let's say 1, 2, 3, 4. That same key you have to specify on the router. And which protocol you want to use? I want to use here right now TACAS. So you are adding this database. I want to provide authentication to this device. Clear this thing? Now here you are creating the user account. Let's say click and the password is 12345. Clear this thing? Any confusion here? So here basically I am creating the database on the Ccna server or Radius server. So my username and password is there on the remote server, on this Ccna server. So here configuration, okay. Clear this thing? Any confusion? Now after that, what you have to define? You have to define Ccna server. Who is your Ccna server and what is the key? So Ccna server host and IP address 10. Then Ccna server key. My key is 1234. Clear this thing? Key is 4. After that, you have to define AAA new model. Then you have to provide authentication. AAA authentication login default. AAA authentication login default group Ccna and local. Then line VTY 0 space 4. Login authentication default. Clear this thing? Login authentication default. Enter. So let's verify first. Can I communicate with one or not? Yes, I am able to communicate. So now try telnet. Telnet 10.0.0.1. Now it is showing the telnet protocol is working. Now what is the username? Quick. What is the password? I think so I give password 12345. Okay. So you are able to log in into the device. And now where is that password? Username and password. That username and password is on the remote authentication server. This Crick username is not exist on the router. Clear this point? Yes, Crick, Daniel. Any
Yes,
confusion
yes.
here?
Yeah, that makes sense.
So this is your remote authentication. There is a discovery number 39. Configure external authentication using Radius and Taka server. Okay, I showed you Taka server. If you want to configure Radius server, just instead of Radius server, sorry, Taka server, you have to type Radius-server. That's it. The rest of configuration will be exactly same. Clear?
So if I heard you correctly, the only difference is the name.
Name, right. The configuration wise exactly same. So just perform that activity. 39.
Understood. 39.
WAN technology.
Sorry, can we take a quick break? I need to use the restroom.
Okay, not an issue. We'll take a 10-minute break and then we'll continue. Fine?
Sounds good.
Okay. WAN technology. In WAN technology, we have lease line, then we have frame relay, MPLS, VPN. In VPN, we have lots of type of VPN. For example, GRE, DM VPN, site-to-site VPN, remote access VPN. Now, lease line. Lease line are end-to-end permanent connection. Between sites. In lease line, bandwidth is fixed. Not scalable. Not scalable in the sense, if you have multiple sites, you need multiple lease line. Fixed path. Fixed path in the sense, let's say if your lease line goes down, then your traffic will be down. The path will be not switch over. So normally we are using lease line as a backup line. Next, we have a technology Metro Ethernet. Now in Metro Ethernet, when we talk about Ethernet, then Ethernet is limited fixed distance. Based on cable. Based on cable in the sense, if you have UTP cable, then maximum length will be 100 meter. Now in Metro Ethernet, it use fiber standard. Support for long distances. So in Metro Ethernet, we use Ethernet in WAN. So there are some special switches which are known as Metro Ethernet switch. So in this technology, there are some special switches used, which is known as Metro Ethernet. For example, there is a switch ME3400, ME3800X, ME9400. These are the Metro Ethernet switches model. Then we have a technology frame relay. Frame relay is now a obsolete technology. No one is using frame relay. It's a kind of layer 2 technology. So for example, you have this headquarter router. These are two branches in different cities. If you want to connect these two branches, and this is the ISP network. So frame relay is a layer 2 technology basically. In this slow bandwidth is slow. DLCI number used as layer 2 address. So in frame relay, basically some special switches use known as frame relay switches. These switches understand DLCI number. So DLCI number is a kind of layer 2 addresses which is provided by ISP. So for example, you want to connect two branches. So you took two DLCI number, let's say 100 and 200. And here we have 101, let's say here 201. If I map 100 to 101 and 200 to 201. So this is the physical connectivity. Inside this, we are mapping 100 to 101, 200 to 201. So this internal mapping is known as virtual circuit. Virtual circuit. So
What kind of mapping?
mapping is like, this is my FR1.
I just want you to repeat what you said. What kind of mapping?
Hold on, I will explain. See, from here to here, this is the physical connectivity, right? Which I take the internet connectivity from the service provider. This is the frame relay switch in ISP. So ISP to your network, that will be the physical connectivity, right?
Does the VC stand for virtual circuit?
Right.
Okay, that's what I was trying to figure out. That's all I knew.
So router to frame relay switch is the physical connectivity. From this frame relay switch to this frame relay switch, we have to make the logical connectivity, and that logical connectivity with the help of DLCI number. If we make a circuit from 100 to 101, this virtual circuit will be established. If we make a connection from 200 to 201, this virtual circuit will be created. Clear this thing? If this link, internal link is up, then your connectivity will be complete.
So then you would have two virtual circuits.
Yes, it depends like what kind of implementation you are doing. If you are doing one-to-one map, that is known as point-to-point frame relay. There is a concept point to multi-point also. On HQ router, you can take a single frame, single DLCI number, and you can connect with the multiple DLCI number. That type of implementation is known as point to multi-point. It totally depends on like how you are implementing your network. This is the example of point to point. Next, we have MPLS. Multi-protocol label switching. MPLS. This is the advanced technology of frame relay. MPLS. In MPLS, packet forward based on labels. So again, this MPLS is 5-day course, so it is a big topic. So you can understand in MPLS, the traffic is forwarded based on the labels. So if you remember in the routing, the traffic is forwarded based on the IP packet. Every router will examine the IP packet, what is the source, what is the destination. Based on that, the router will forward the packet. And every hop, every router will open that packet to check who is the destination. But in case of MPLS technology, whenever the router receives the packet, it will just read the label. It will not open the entire IP packet. It will not check who is the source, who is the destination. No. It will just simply check what is the label. So based on the label, it will forward the packet. Next is VPN. Now what is VPN? VPN is a technology or a mechanism to connect two or more private network over public network. This is my private network. Private. If you want to connect, you are taking help from the ISP, and that ISP is my public. So in this VPN is again a big topic. We are going to discuss a type of VPN which is the GRE tunnel. GRE. generic routing encapsulation. GRE is a point-to-point tunnel data travel in clear text form. GRE developed by Cisco. So GRE is a point-to-point tunnel. GRE. Work on port number 47. GRE can encapsulate any layer 3 information. So it's like this way. So we are making a GRE tunnel here. So once this GRE tunnel is configured, so if you are sending traffic from here to here, so how your traffic will move? The traffic will be go to the ISP1. ISP1 will forward that traffic to ISP2 directly through the GRE, and after that traffic will move to. So my traffic will be hidden on the internet. Now GRE is a point-to-point tunnel. So if you have multiple sites, in that case, GRE is not scalable. So for that, we have an advanced concept, DMVPN. DMVPN is dynamic multi-point VPN. It is point to multi-point. Automatic tunnel can be built between all sites. It's a hub and spoke network. Hub and spoke means there will be a headquarter router which is working as a hub, and the branches will be spokes. Next is GRE configuration. Just a second. Okay. So I'm showing you the GRE configuration in this advanced software. This is the GNS3 like your packet tracer, but in packet tracer, I'm not sure that GRE will work or not. That will work here. Okay. And I can show you the particular packet of the GRE also, because in this software, Wireshark is inbuilt. So that is a better software to implement the advanced things. So here, so let's say this is my internet network. Okay, let's understand this topology now. Let us assume this router R2 is my internet router, or this is the external internet. R1 is my ISP1. This router is my ISP2. This is my branch 1. This is my branch 2. If this is my internet, so in that case, that will be the public network. So let's say this IP addressing. This is also my public network. So let's say 14. And these are my LAN 192.168.1.0/24. That will be the GRE tunnel. Every GRE is having a different IP subnet. So let's say for the GRE, I'm using 192.168.100.0. That will be the GRE subnet. So, dot 1 is here. Dot 2 is there. Dot 2. This is my complete topology. Yes. Any issue in the topology?
After seeing the topology, can you open up your explanation of GRE again?
Sure. I have to open.
Thank you. Okay, thank you.
Okay. So now the first point is, let's say there is no GRE right now, and if you implement routing, then what will happen? If the routing is configured fine, and I want to communicate this network to this network, so how the network will go? So firstly, the traffic will go to the ISP1, right? ISP1 to the internet router to the service provider, and the service provider to the branch. Clear this point? We will never implement routing with the external world, with the internet, because if we implement any kind of dynamic routing, then what will happen? My internal network information will be on internet, which is not good for the security purpose. If someone knows about your internal network, he can attempt a lots of attack, right? So we always build some kind of tunnels to make connectivity between the branches. So when we make the tunnel, then our traffic will firstly go to the ISP1. ISP1 will put that traffic into the tunnel, and through tunnel it will reach directly to the ISP2, and ISP2 the destination. It will never go to the internet router. Clear this thing? Any question here?
No, that makes sense.
Okay, so we are going to implement the same thing. So I will try to write everything in the screen. Now, so I'm not writing the IP addressing configuration task. Okay, so IP addressing, you know very well how to configure IP addressing and the routing part. Clear? So GRE config. Step 1. Configure IP addressing. So these command I'm not writing because we have less space here. So that task I'm doing little bit fastly. So whatever Cisco lab you are accessing now, they are using this same software. So this is my branch 1 router. So font size is okay, or should I increase the font size?
No, it's okay.
So let's say I change the host name DR1. So here we have to configure a interface fast Ethernet 0x0, and IP address is, let's say, 14.0.0.1, 255.0.0.0, no shut, exit. There is a LAN network. For LAN, I am creating a loopback interface. As I already told you, loopback interface is a virtual interface. 192.168.1.1, 255.255.255.0. No shit. Exit. If I run here, do show IP interface brief. You can see interface IP addressing is working fine here. R1 router, which is ISP1. So here we have interface fast Ethernet 0x0, IP address 14.0.0.2, .1. Okay. IP address is configured fine here, not an issue. R2. This is my internet router. IP address is configured fine here. R3. Everything is working fine here. Last router. So IP address is configured fine. So in IP addressing there is issue. Anything?
Not at the moment.
So there are lots of tunnels. IPv4 to IPv6 tunnel, GRE tunnel, DMVPN tunnel, site-to-site VPN. When we are creating remote access VPN, again that is a tunnel, right? You are connecting through VPN, remote access VPN, that is a kind of tunnel. So to make any tunnel, source and destination must be reachable. Source and destination must be reachable means step 2, GRE configuration. To make any tunnel, tunnel source and destination must be reachable. So we have to make a tunnel between ISP1 and ISP2. So firstly check, can I communicate ISP1 to ISP2 or not? This is router 1. So if I'm here, do ping no, I'm not able to communicate. Why I'm not able to communicate? Because I just configured IP addressing. There is no routing here till now. So to make communication, what I'm doing, I'm creating a default route. With ISP, we always use default route. And same way on R3, IP route. So now try to ping. You can see now I am able to ping. So if I am able to communicate with ISP number 2, then I can form the tunnel. So to configure a tunnel, interface, tunnel, any tunnel number, let's say tunnel 0. As I told you, every tunnel is having a IP address. So IP space address 192.168.100.1. That is the tunnel IP address. Next point, you have to define what is the tunnel source and what is the tunnel destination. Tunnel source this is the tunnel source. Tunnel destination this is my tunnel destination. Next, you have to define tunnel mode. Tunnel mode is GRE, and inside the GRE IP. Why IP? Because we are configuring GRE IP, IP version 4 tunnel. So how many command I run here? Do show history. I use this command, interface tunnel 0. See the configuration. So I'm making a tunnel here on ISP1 and defining the tunnel is 0, tunnel number is 0. The tunnel IP address is this 192.168.100.1. Then tunnel source. Tunnel source will be this IP address 100.100.100.1. From this interface I am initiating the tunnel, and where my tunnel will terminate on this interface, which is 101.101.100.1.1. And then you have to define the GRE mode. Clear this thing?
Yes, sir.
GRE.
So just to be clear, are you tunneling through the internet router or is it bypassing it?
Through the internet router.
But it's tunneled so that the information's private.
Yes.
Okay, gotcha. Thank you.
Because your information will be hidden. Actually, what is happening right now, if you are not creating this tunnel, so that internet router can see your packet. But now, when you configure the GRE tunnel on your IP packet, this tunnel will add one more encapsulation. It will wrap your data with the GRE header. So if someone get the packet, so it will get, okay, it's a GRE header. They cannot see what is going inside the packet.
They only see that it's just a GRE header.
Right. So same type of configuration will be on ISP number 2. So if I write configuration here, what will be the configuration on ISP 2?
Well, the tunnel source is going to be 101.101.101.1.
Yes.
And then the destination will be 100. And you already changed the IP address.
Right or wrong?
That looks right.
I can simply copy this syntax and I can directly paste into router 3. So we are getting the message line protocol on tunnel 0 change state to up. That means my tunnel is up. So to verify more, we can run the command show interface tunnel 0. So if you see this output, this is showing tunnel 0 is up, line protocol is also up. This is my GRE tunnel IP, and somewhere, see this. My encapsulation protocol is right now GRE tunnel. So my tunnel is established. Now you have to define routing part. Means you have to run any routing protocol inside your network, not on internet side, inside your network. So I'm running EIGRP here. So firstly on branch, which is R4, router EIGRP 100, then network 192.168.1.0 and network 14. And exit. If you are on branch 2, so on branch 2, that will be 2. Here will be 35. Next, on service provider router. Here you have to advertise your internal network, which is 14, and the GRE network, because your traffic will move through GRE.
Do you have to do it on both ISP routers or just on the first one?
No, on both the. It will be R3. So this is the full configuration. You just read once and then we'll verify. Ask any question if you have. So firstly, I just configure IP addressing. After IP addressing, I configure the GRE tunnel. For the GRE tunnel, we need source and destination must be reachable. For that, I just create a default route pointing towards internet router so that they will communicate. Once they start communicating, then I configure the GRE tunnel. Inside the GRE tunnel, I define a tunnel number, which is tunnel 0. Then I define a tunnel IP address. In that tunnel, I define what is the source and what is the destination IP, and then tunnel mode. So that configuration will be on ISP1 and ISP2. Once my tunnel is established, then I have to perform routing so that my traffic will move from branch 1 to branch 2.
Does it matter if you do it in a different order, like if you do branch 1 and branch 2 configuration before the ISP 1 and 2, or does it have to be in that specific order?
No. There is no specific order. You have to run all these commands.
Just as long as you do all the steps, you're okay.
Yeah.
In the EIGRP protocol, you could have used a different protocol as long as you stuck with
Yeah,
the.
it's a internal site. You can rip EIGRP host with any protocol.
Okay.
Let's verify now. Okay. See, let's say you are on branch router. Where is R4? Let's try to ping 192.168.2.1. You are able to ping. Now, if I trace route, same IP address, see the output carefully. So firstly, my traffic is going to ISP1, which is having 14.2 IP address, right? Then ISP1 is forwarding that traffic to the GRE tunnel right now. So in the GRE tunnel, you can see the IP 192.168.100.2, which is the IP address of ISP2 GRE, right? And then it is reaching to the destination. Clear this thing?
Hold on, leave that up just for a second.
So in actuality, it's traveling through the 100 and 101 networks, but it sees that it's going through the tunnel network, correct?
Right. Every tunnel work on the same process.
Okay, I'm good.
Okay. So let more verification. In this, there is a Wireshark. So let's see the packet. My GRE's header is attached or not. So let me send the traffic once again. So here these ICMP packets. these ISMP packets are going through this GRE right now. If you want to see, you can see this output.
And I'm sorry, is that the data on R2 or the data on the connection between R1 and R2?
The data is going between, firstly traffic is coming to the R1, R1 to R2, R2 to R3, and then this router. Physically,
Right,
the data is traveling like this way, no?
No, right. I see that it's going through R2, but when you're doing the Wireshark capture, are you looking at the connection between R1 and R2, or are you looking specifically at R2?
No, between R1 and R2, because my actual data is traveling on that link.
Okay, thank you.
So if you see this thing, firstly, this is my payload, Internet Control Message Protocol. Whenever we are doing ping command, inside the ping, this ISMP protocol is working. So this is my payload. This is my data, ping data. Okay. On that ping data, there is a IP header, IP protocol information, IP header. On the top of the IP, there is a GRE header. So data is wrapped. The encapsulation is now GRE. So on that GRE, when the packet is going on internet, there is no identification. No one can see. There is no address. Clear this thing? And this information, internet, this is the GRE information. What is the GRE source and what is the GRE destination?
So if anyone was to capture packets, all they would see is the GRE above and above. They wouldn't see anything below it.
Right. So you can see the GRE protocol number is 47.
It's pretty sneaky.
Through the Wireshark, you can capture anything.
And Ethereal works the same way, correct?
Sorry?
Does Ethereal work the same way?
Right. But I haven't worked on Ethereal. So I always work on this thing. So this thing is clear, GRE tunnel. Let me take a screenshot of this.
Rakesh, how long have you been doing these classes?
Which one? CCNA?
Which one? Yes, CCNA.
From last 10 years.
Oh, okay.
So
It shows.
basically, I work on approximate all the versions. Like I'm not just taking CCNA batches. I'm taking various technology. For example, like CCNA, CCNP, CCI written, advanced BGP, MPLS, and then we have data center technology, CCNA data center, Nexus, UCS, sometime firewall.
So are you?
Sorry?
No,
So-
go ahead, Daniel.
I said, are you certified?
Yes, I'm certified in Cisco, in HP.
And you have to retake it every 3 years?
Yes. So no need to do an like recertification in every 3 years. If you do advanced certification, for example, like today you are CCNA certified. So after 3 years, it will expire. So better to go into the next certification, go with the CCNP. So if you are certified into the CCNP, automatically your CCNA will be recertified automatically.
Oh, okay. So just take the highest next one up, and then
Right.
the other one kicks back in. Gotcha. I was wondering how it carried ongoing instead of having to take each one. That makes sense.
Yes, Craig, you are asking something.
No, that's okay.
So there is a discovery number 50. So
You should
perform
just
that
go.
activity.
Let's go.
Discovery number 50, configure and verify GRE tunnel.
Understood. 15.
So CHAP authentication. So as we discussed, like in WAN, we had two encapsulation, HDLC and triple P. So HDLC is not provide any authentication, and that is the by default encapsulation. Triple P provide authentication. In triple P, we have PAP and CHAP. So these are the differences between triple P and HDLC. Now, PAP is a two-way handshake authentication. Two-way handshake authentication means whatever username and password you configure on router 1, it will exchange with router 2, and it requires the same type of authentication from R2 also. So that username and password will be stored on the locally on the device, on the routers. So now here, how we have to implement CHAP. So to implement CHAP, let's say we have these two routers which are connected with a serial link. So let's say serial 0 by 0, serial 0 by 0. If you want to implement CHAP authentication here, so first thing, on both routers, you have to go to the interface serial 0 by 0, and you can define first thing encapsulation triple P. By default, encapsulation is HDLC. If you want to change the encapsulation, then the command is encapsulation triple P. Once you define the encapsulation, you have to define triple P authentication CHAP. After that, on R1, you have to define a username. For example, like username R2, you have to use the same host name, and password, let's say 123. Same way on R2, username R1, password 1, 2, 3. That's it.
So you're putting the username and the password of the other router on each router.
Right. Username must match remote host name. For example, so I'm assigning an IP address to that serial interface. So we assign the IP address. Now let's try to ping. I'm able to ping. So that means everything is working fine. So first command is show interface serial 2x0. So in this, if you see, the encapsulation is HDLC. By default, encapsulation is HDLC. Same way here, do show interface serial 2x0 HDLC. So right now there is a communication. What will happen if I change the encapsulation? Let's say encapsulation interface serial 2/0. Here I'm changing the encapsulation triple P. If I change the encapsulation on one router, you are unable to communicate. So for the communication, if you are connecting through serial link, make sure your encapsulation must be same on both the routers. Let's see why the communication is not happening. Show interface, show IP interface brief. So here you will see your port is up, but the line protocol is down. Why this down? Because the encapsulation is mismatched. So if I configure on R1 also encapsulation triple P, that will be up. and after that if I try to ping, that communication will be done. So this is the basic lab of P. Now next, how to configure authentication, CHAP authentication. So for CHAP authentication, first thing you have to create a username. So let's say I create a username R2, password 123. Same way on R2, username R1, password 123. Password must match. After that, interface serial 2x0. Your first command is encapsulation P, then P authentication CHAP. Exit. Same command you have to run here. So once you run this command, P authentication, so P authentication is configured. How you have to verify? Debug P authentication. So for the verification, what I'm going to do, I'm just shut down that serial interface. Shut down and then no shut. So this is the CHAP authentication, you can see. So before sending any kind of link activation, it is performing the CHAP. If the CHAP authentication is working fine, then only the line protocol will be up. So here you can see it is sending the challenge. Somewhere you will get the response, send authentication, and here CHAP is login done. Login pass. So after that you are getting this thing. Line protocol status is up. Clear this thing?
Yeah, that all makes sense.
Next. PAP authentication. Right now, no one is using PAP authentication just because the username and password will be into the clear text form.
I'm sorry, say that again?
No one is using PAP authentication because the username and password will be into the clear text form. Anyone can read the password.
Understood.
The configuration will be same way. Username R2, password let's say 123. Then R2, username R1, password 123. Then on R1, interface serial 0 by 0, let's say it is 0 by 0. Encapsulation triple P. Triple P. Authentication. PAP. Triple P. PAP. Send username. Your own username and the password 123 and exit. Same type of configuration will be on R2. Interface serial 0 by 0. Encapsulation triple P. Then triple P. Authentication PAP. Triple P. PAP. Send username. Username is R2 and the password is 123. That is the PAP configuration. If you want to verify this thing, so let me first remove the chap. So chap is removed. So first thing, you have to create the username. Then we have to configure PAP. So let's say interface serial 2 by 0. Encapsulation triple P, first command. Triple P. Authentication PAP. Triple P. PAP. Send username. Username is R1. Password 123. Exit. Same kind of configuration here. Interface serial 2 by 0. Encapsulation triple P. Triple P authentication. PAP. Triple P PAP. Send username R2 and the password will be 123. Let's do the same kind of verification. Again, I'm going to serial interface serial 2 by 0. Shut. And then no shutdown. So this is the PAP authentication verification. So once PAP authentication is passed, then only the state will be, line protocol will be up. Clear this thing?
Yes, sir.
So the only difference then between PAP and CHAP is that PAP stores the passwords in plain text and CHAP is encrypted,
Right,
but they both do the same thing.
right.
Okay.
So this is the discovery number 47. Perform that activity.
47. Got it.